Next question, the major product formed in the following reaction sequence is. So this is a pyridine derivative, 3 substituted pyridine derivative, which is treated with tertiary butyl lithium in diethyl ether minus 78 degrees centigrade, and then ethylene diiodide. So what will happen here? This is an example of directed orthometallation reaction. Directed orthometallation reaction, that means DOM reaction. So what will happen here? This oxygen with its lone pair will direct the base to abstract proton orthoposition to this group. That means it has 2 orthoproton, this proton and this proton. Now which one will be abstracted? This is our question, but first I am telling you the answer. This tertiary butyl group will preferentially abstract the proton at 4 position, and corresponding conjugate base will be formed, and after that ICH2I, one iodine will be taken, minus CH2 double bond CH2 minus I minus. So the product will be an iodine at para position. So why this proton will be preferentially abstract? Two reasons are given for this purpose, because first is that nitrogen itself has one lone pair of electron, and if the anion generate here, then these 2 electron pair will repel each other, and that's why this proton will be preferentially abstracted by this base. And the another reason is that, as we know that in sp3 hybridized orbital, the bond angle is S character is 25%, while sp2 will have bond S character will have 33%, and S character 50%. That is, the S character increases from sp3 to sp2 sp, and bond angle also increases. In this case 109 degree, 120 degree, this is 180 degree. Now one experimental thing which is observed in pyridine, in case of pyridine, is that the bond angle of this bond, the bond angle for this bond, carbon-carbon bond, is 4 degree greater than the normal value of 120 degree. That means it is 124 degree. It is sp2 hybridized, so it should be 120 degree, but it is 4 degree greater than 120 degree. It is actually 124. So as the bond angle increases, that means S character increases. So this orbital will have greater S character, and that means this orbital will have greater P character. So lesser S character. On the other hand, if we take this bond angle is 1 degree smaller than the normal value. That means these bond angles are 119 degree, and that means that this orbital will have greater S character. As the S character increases, acidity increases, and that is why the base preferentially abstract proton from position 4. So the next question, the major product formed in the following reaction is. So here, as you can see guys, this is an intramolecular aldol reaction. So this base will preferentially abstract proton, and here two different positions are available to abstract proton, that is this position, this hydrogen, and this hydrogen, because these two hydrogens are equivalent hydrogen. That means two positions are possible. And now if the base preferentially abstract photon from this hydrogen, then a negative charge will be formed here, and it may attack in two ways. That means it may attack into this carbonyl carbon, or it may attack into this carbonyl carbon. Let's say this is A attack, this is B attack. A attack leads to a 1, 2, 3, 4, 5, 6 member ring, whereas B attack leads to 1, 2, 3, 4, 5 member ring. Now, as we know that the rate of formation of 5 member ring is greater than the rate of formation of 6 member ring, and that's why the 5 member ring will be form first, and the major product will be a 5 member ring. So the product will be, this is let's say this is the keto, this carbon is attached to this carbon, so here 1 O minus, 1 CH3, and CH2 COCH3 will be on this carbon, CH2 COCH3. So actually it will be a double bond will be here. First it will be converted to OH, and then one molecule of H2 will be removed. There will be a double bond here. So this compound will be formed as the major product. And now I am telling that if the proton abstractions take place from this carbon, then what will happen? Then the negative charge this anion will be formed, and this anion may attack into this carbonyl carbon, or may attack this carbonyl carbon, and both of this will give the similar product because these two groups are equivalent. Now this abstraction of proton will not happen, and it will not be the major product, because here if we see the statistical probability of abstraction of proton, then number of protons of these two this kind are 6. Here 3 numbers of hydrogen, and here 3 numbers of hydrogen. So total 6 number of hydrogens are equivalent, whereas this kind of proton are only 3 protons are there. So there are much probability to proton be abstracted from this position. So the product will be this. Whereas if we see the options, then this is the correct option. This is the correct option. If you have any doubt regarding this, please let me know in comment box. To get such interesting videos, subscribe my channel. Thank you. Have a good day.